This page of this assignment doesn't have anything for you to answer on it, but there is important information. So remember the linear functions that Michelle and Myra wrote in the previous page. And they're equivalent equations, functions, but they have different forms. One of them look like this. That's called factored form, when you've divided out or factored out the term that these terms had in common. So this is called factored form because a term has been factored out, this 15 in this case. This form is called general form. And you'll notice down here, it mentions that that form looks the same as slope-intercept form, y equals mx plus b. And if you look here, you'll see it's true. This is like the y, this is like the m or the slope, this is the input or the x, and this is the b, negative 45. So plus b is plus negative 45. So our y equals mx plus b, or slope-intercept form, is what they're referring to as general form. So nothing new there except for these terms. Now, linear functions and other functions too are often called polynomials. And a polynomial, there's a definition here that it's a mathematical expression involving the sum of powers in one or more variables multiplied by coefficients. All those words are saying is you'll have different terms, and those terms will be separated with pluses and minuses, because adding a positive is and adding negatives, those are all considered sums. So, for example, here's a polynomial, 3x squared minus, let's say, x, plus 44. Okay? This is a polynomial because it's got multiple or poly terms. This is a term, this is a term, this is a term. And some of the terms have coefficients. So this is a coefficient, this number out in front of the variable, right? There's an invisible coefficient right here, that's a 1. So, and you can also have constants, numbers that don't have variables. So technically, there's also a variable here, but it's to the 0 power. So anything to the 0 power is 1. So 44 times 1 is just 44. So we're going to ignore that. But this is a polynomial. Then the degree of a polynomial is the highest exponent that's on a variable. So in this case, the degree of the polynomial is 2. It's a second degree polynomial because the highest exponent is a 2. Okay. Then there's another term here, and that term is leading coefficient. So what you do to find the leading coefficient is you look at the term that has the greatest power. In this case, 2 is the highest exponent or the highest power, and then you look at the leading coefficient of that term. So 3. So the leading coefficient of this polynomial is 3. All right. So those are those terms. Now, if you scroll down here, this just gives some examples. So these are all polynomials. This is a polynomial even though it only has one term. A monomial or a polynomial with one term is still a polynomial. This polynomial is a linear polynomial because if you graphed y equals this times x minus 5, it's like y equals mx plus b, that form, that's linear. Constant just means it's a number with no variable. Linear looks like the ones we've been working with. Quadratic are the ones that have a power of 2. Cubics have a power of 3. So these are all polynomials. This polynomial has one term. This polynomial has two terms. This polynomial has 1, 2, 3 terms. This polynomial has 2 terms. And then this is the degree. So 7 is the same as saying 7 times x to the 0 power, because that's 7 times 1. So because this x has a 0 exponent, it's a 0 degree. This x has a 1 by it. We don't need to write it because x is the same as x to the first. So this is a first degree polynomial. This 2 makes this a second degree polynomial. This 2 right here. And this 3 makes this a third degree polynomial. So that's what those terms mean. Why they're mentioning this now is that these polynomials have different shapes when you look at them on a graph. Some of them, like a linear, we're looking at linear now, those look like lines, right? Quadratics will look like parabolas or these curves, either like that or like this. Cubics will look like this. That's not a very good drawing, but that's what cubics look like. And so these polynomials, when they're on a graph, when they're on the coordinate plane, it's going to tell you the maximum number of times the graph can cross the x-axis. So linear equations, maximum, are going to only cross once. Quadratics, maximum, are going to cross no more than twice, maybe even less, but the maximum of 2 times. Cubics are going to cross a maximum of 3 times. So these numbers will tell you something as we go through the class about what's called the x-intercepts, and that's leading into what we're going to study now, the times that the function crosses the x-axis. And then in the next part of this lesson, we're going to be looking at this general form. And we're also going to be looking at the factored form. So we're going to be looking at the factored form and the general form.